Okay, so these are the most important categories in terms of identifying or distinguishing these three types. So let's go through this really quickly. So what did we say the oxidative capacity is for oxidative, slow oxidative fibers? High, right. What is it for fast oxidative fibers? Also high, right? They're oxidative. So that means they're relying mainly on what? Oxygen to complete what process? Oxidative phosphorylation, exactly. What about fast glycolytic fibers? None, right? This is going to be decreased. They're not reliant on oxidative phosphorylation, so they have a decreased oxidative capacity. Let's look at glycolytic capacity. For slow oxidative fibers, what's that going to be? It's going to be decreased, right? These slow oxidative fibers don't have a very high glycolytic capacity. They don't have enough of the enzymes, they don't have enough of the glycogen stores, and so they're going to have a decreased glycolytic capacity. Likewise for the fast oxidative fibers, okay? For the fast glycolytic fibers, we do see a high glycolytic capacity. And again, that translates to glycogen stores and then those glycolytic enzymes. Let's look at the contraction speed. What is the contraction speed of slow oxidative fibers? It's going to be slow, right? Again, the first name is telling us about the type of myosin ATPase activity. So we know that the contraction speed here is slow, whereas for these two types of fibers, it's going to be fast. For fast oxidative, it's actually not going to be as fast glycolytic. So we're going to just put this dash, which means intermediate, okay, intermediate. So slow oxidative fibers have a low conduction speed. Fast glycolytic fibers have a high conduction speed. And then fast oxidative fibers are kind of in the middle with that medium or intermediate speed. Let's look at the mitochondria. So where do we have more mitochondria? What fibers? Right, it's going to be our oxidative type. So we're going to see more mitochondria here. We're going to see more mitochondria here. We're going to see less mitochondria here, okay? As long as we have oxidative in the name, that's telling us the primary source of ATP production is oxidative phosphorylation. That should automatically translate to you more myoglobin, more mitochondria, okay? And more capillaries, right? The capillaries that are helped to bring that oxygen in. So because we have slow oxidative fibers and fast oxidative fibers, we're going to have more capillaries here, less capillaries here, okay? That's going to be the same for myoglobin. More capillaries, more myoglobin, less myoglobin. What is the function of myoglobin? What's the function of myoglobin? It's bringing in oxygen, right? It's a transporter protein that's helping to transport oxygen to these muscle tissues. So it makes sense that we see more myoglobin in the same place that we see more capillaries, in the same place that we see more mitochondria, right? That is all facilitating that oxidative phosphorylation. Let's look at fatigability. Now, which of these fibers is going to fatigue the easiest? The fast glycolytic, right? I hope that's what I'm hearing. The fast glycolytic, right? Why are they going to fatigue the easiest? Why are the fast glycolytic going to fatigue the easiest? We said two reasons. One, because anaerobic glycolysis does not produce as efficient a source of ATP as oxidative phosphorylation. And then what was the second factor that contributed to fatigability with these types of fibers? The production of what? Lactic acid, right? Lactic acid. So we have a high fatigability or a decreased resistance to fatigue. So be careful with the wording there. You'll see that worded two different ways. A high fatigability, but a decreased resistance to fatigue. All right, so let's see about the fast oxidative fibers. They're going to be sort of intermediate in their level of fatigability, right? Not as easy as fast glycolytic, but not as resistant as slow oxidative. Whereas the slow oxidative fibers are going to not fatigue as easily, okay? So we're going to have a decreased fatigability. Again, make sure you pay attention to the wording with fatigability. That can be worded two different ways. Let's look at the color here. So what's the color of slow oxidative fibers? Red, good. So they're gonna be red. Why are they gonna be red? Not more oxygen. Why are they gonna be red? More myoglobin, okay? More myoglobin, very important. So the myoglobin is what's making these fibers red. Again, that is indicating to us that bringing in oxygen, but the actual red color is contributed by the myoglobin, okay, not the oxygen. And then these fibers are gonna be what color? White, right? So the absence of that red pigmentation is gonna leave these fibers white. Let's look at the fiber diameter here. So what is the fiber diameter for slow oxidative fibers? Are they small or are they big? They're small, right? They're smaller fibers. Whereas our fast oxidative fibers are sort of in the middle or intermediate. And then our fast glycolytic fibers are large diameter, okay? They're gonna generate more force. They're gonna be recruited last as far as the size principle, right? They're gonna be attached to larger motor units. And so we're gonna recruit them last. What types of activities do we recruit these types of fibers for? What types of activities do we recruit fast glycolytic fibers? Sprinting, right? Sprinting, heavy lifting, vigorous activity, okay? They're gonna generate more force. They're gonna be excited more quickly, right? But we're gonna feel that burn much more earlier because of the lactic acid. What types of activities do we recruit slow oxidative fibers for? Jogging, light exercise, our day-to-day activities, okay? So, this is really important to be able to distinguish these types of fibers, where they get their energy, their contraction speed, and all of that good